In 2.19, we are asked to show that when energy is a function of the Planck's constant, mass, and length, which is this, we need to prove that, let's say energy is h to the some function where it's h to the power a, m to the power b, and l to the power c. We need to prove that the dimensions of energy will only be satisfied when a equals 2, b equals -1, and c equals -2. So the dimensions of energy can be written in terms of mass, length, and time. Just gonna explicitly write it so there's no confusion. The square brackets here tell you that I'm looking at the dimensions of energy, right? And the SI unit of energy is 1 joule, right? 1 joule is 1 Newton times 1 meter. 1 Newton is kg times 1 meter per second square times meter. So, so in this case, we have, this is the dimension of mass, right? So we have one mass term raised to the power 1. And this is the dimension of length, which is raised to the power 2. And this is the dimension of time, which is raised to the power -2, right? So we need to show that h to the power a, m to the power b, l to the power c, the dimensions of this should be equal to this. So yeah, we know that the dimensions of this should be equal to this if energy is a function of something like this. And what we need to show is that a is 1, b is 2, and c is -2. So this is what, sorry, I just messed up the labeling. So we need to show that a is 2, b is -1, and c is -2. So let's first write the units of Planck's constant. The units of Planck's constant are joule second. The units of mass, the SI unit, I'm only going to write the SI units for now. Mass is a kilogram, and the SI unit of length is 1 meter, right? So 1 joule can be written as 1 kg meter square per second square times second from here. So this will be equal to 1 kg meter squared per second, right? So now if I were to write the dimensional, the dimensions of something of h to the power a, m to the power b, l to the power c, it would be kg meter square per second to the power a, kg to the power b, meter to the power c. Now, the dimensions of this will give me, this is the unit of mass, right? So m to the power a, length to the power 2a, time to the power -a, and mass to the power b, and length to the power c. Now, I am going to put the like terms together. So this will be m to the power a plus b, and length to the power 2a plus c, and time to the power -a. Now this has to be equal to this value, right? So this should be equal to m to the power 1, l squared times t to the power -2. So if we equate the powers on either side, this is what we get, right? So this would give us A equals 2, right? And so this would be 2 plus B equals 1, which implies B has to be -1. And this would be C has to be -2. So we actually proved that A is equal to 2, B is equal to -1, and C is equal to -2.